Okay, let's continue. Now we'll talk about some maintenance tasks. Maintenance is a very broad term. For example, setting up message logs is maintenance, and we already discussed it. Backups is maintenance, and we will talk about it later. And in this topic, we will talk about vacuuming and what tasks vacuum performs, and about indexes, monitoring of indexes, and rebuilding indexes. So, about vacuum. We already discussed vacuum yesterday, but besides cleaning up your tables from dead raw versions, vacuum performs other very important tasks. It updates statistics, updates visibility map, free space map, and it doing a thing which is called freezing to prevent transaction ID wraparound. So let's talk about it. Vacuum. As you remember, I believe, vacuum is command that reads your tables, finds raw versions which are no longer needed, and deletes them physically from pages to free up some space for next upcoming raw versions. Vacuum works concurrently with other activities in your database. It doesn't lock tables, so you can do selects, updates, and so on, any command you want, together with vacuum, so it is not blocking. You can run vacuum manually by vacuum command. You can specify table or just vacuum all database, but it is not clear how often you should do vacuum, because if you do it frequently, you just generating excessive input-output operations, and when you do it infrequently, you get your tables bloated. So we need some means to react to rate of changes in your table, and this is done by auto vacuum process. Auto vacuum reacts to the rate of changes, so if your table is changing actively, auto vacuum will vacuum it more frequently, and the table which is more or less static will be vacuumed less frequently. So it is very convenient. When auto vacuum is correctly configured, it works smoothly and vacuums table in time. Also, we have vacuum full command, which reconstructs all table and all indexes on this table from scratch. It is blocking command. It acquires exclusive lock on your table to reconstruct all files of this table.
So what it does, a complete rebuild of the table?
Yes, it creates new data files from all forks of this table and new data files for all indexes, and then deletes old files and switch system catalog to new ones. So it's brand new files. They are compacted but it takes time and it requires exclusive locks, so you cannot do anything with your table, including selects. Interestingly, that truncate command in Postgres works about the same way. It requires exclusive lock on a table, and when you commit your transaction, it just removes all files that you have and replace them with clean zero size files. So it is very fast, but it locks your table until the end of transaction. Besides this, vacuum performs another set of operations. First of all, it updates statistics, and by these statistics I mean statistics for planner, for optimizer. You can collect statistics manually by analyze command, or you can combine vacuum and analyze in one command. You can run vacuum analyze like this. It will perform vacuum and then analyze your table. But usually statistics is collected by auto vacuum process, which just run analyze reacting on rate of changes in your table. If your table changes frequently, then it will be analyzed frequently. And this way you get actual statistics. Yeah.
What's the difference between analyze only and analyze?
Between these two commands, you mean?
Vacuum DB
Yeah.
dash analyze only.
Vacuum DB is just an operating system wrapper on vacuum command. So when you run vacuum DB, it means that you vacuum table, and analyze only performs just analyze.
Right.
So analyze and vacuum DB analyze only the same things, are the same
I
things.
mean down below.
Here. First command just analyze data that you have in table, and the second one first vacuum table and then analyze it. That's all the difference.
But it is not analyze only.
Actually.
Why?
It's both, as you said.
Analyze only performs analyze only, and analyze performs vacuum and analyze.
You also need to give the table name.
To vacuum DB,
It's analyzed and then you need to give the table name?
yes, you can give table name. If you don't, then it will analyze all your database, all tables in your whole database. This is very important because
You can analyze just one schema.
I'm not sure. Maybe you can specify schema, but I'm not sure. You can see it in documentation on syntax on this command. Anyway, you can query all tables in your schema and run vacuum for each of these tables. So it is doable, at least. It's very important because statistics is a basis of good plans. If you have outdated statistics, planner cannot generate good plans. So if you have some problems with performance. First of all, you must check that you have actual statistics, and only after that investigate further what's going on. The second task is update of visibility map and free space map. I like today say a couple of words about visibility map. Let's visibility map tracks pages which contains only actual raw versions. So raw versions that are visible in all possible snapshots. So if we have data page which contains only such raw versions, we don't need to check visibility. We just know that these raw versions we can get to client without visibility checks. And indexes in Postgres doesn't contain any visibility information. So if you get a pointer to some row in a table, you must go to table and check visibility. But if this page is in a visibility map, you don't need to go to page. And so you generate less input-output, and it's better. And also, visibility map is used to optimize vacuum performance, because if some page is tracked in visibility map, then there is no job for vacuum in this page no more. So vacuum will not look into such pages. So when vacuum deletes rows from your pages, it checks whether this page contains only actual rows. And if so, it checks this page in visibility map. And any subsequent change in this page will remove this page from visibility map. And free space map tracks free space in your pages. When you select, when you insert new row version, you have to find a page for it, and you can do it very quickly by looking into free space map. So vacuum, after cleaning up dead row versions, updates visibility map, updates free space map to indicate that you have more free space in your page. All of this is doing happens automatically, so you just need to know that it works this way. And another important task is preventing wraparound. Yesterday I told you that transaction ID is always increasing number, but transaction ID is 32-bit counter, so it can overflow, and then it wraps around and becomes 0, and you start from 0. But Postgres relies on this counter to be increasing, because it uses transaction ID to order transactions, to order information. So all space of transaction IDs is kind of looped, and for each transaction ID you have half of this loop, half of this circle behind you, and it is your past, and one half of this circle ahead of you, and this is your future, like this. For this transaction, green part of the circle is future, and rose part is past. And you get increasing numbers. No matter what is the number, you always have one half behind and one half ahead. And transaction IDs, which are quite old, can become visible. For example, if you have these transactions, we get new transaction ID, and for this transaction ID is in future, not in past. So it can become visible, and this is a problem. That's why Postgres performs so-called freezing. It finds raw versions with xmin, with quite old xmin, and replaces these xmins by kind of infinity, which means that this raw version was created far in the past, and it is visible to all transactions, and we don't have to check transaction IDs. We just know that this transaction ID happened far in the past. This is called vacuuming, and it is performed by auto-vacuum process as well. This is another reason not to switch auto-vacuum off, because in this case we will have problems with wraparound. Okay, two indexes. Any questions about vacuum? No? Good. Now to indexes. Indexes are quite complex structure comparing to tables. Usually it's tree-like structures. So we have some we can have some problems with indexes. Index can get bloated. First of all, because your vacuum can be delayed, and so you get more rows in your indexes, and then it is vacuumed by size of index didn't decreased. And you can have excessive indexes. Postgres allows you to create index on the same columns as another index that you already have. So you can create two identical indexes, or you can have indexes which have overlapping columns. Say one index on A and B column, and another index on A, B, and C column. And one of these indexes you can just drop, and it will be almost the same. Excessive indexes and bloated indexes slows you down. It takes additional space on disks and all backups and so on. So you may want to monitor indexes, monitor their sizes, For that you can use pgRelationSize function and see whether it is growing. You can use pgStatAllIndexes table and look at IDX scan column, and if you see 0 in this column for a long time, this means that this index is not used at all, so probably you can just drop this index. And also you can use queries to pgIndex table to find indexes with overlapping columns and analyze them and decide to drop some of your indexes too.
Is there a way to force Postgres to use a specific index?
No standard way. Optimizer decides it by itself, but there are some extensions which brings hints to Postgres, like Oracle, or there is extension which allows you to exclude some indexes from planning and so on. So there are different tools, but these are not standard tools. If you see that your index is growing very large and becomes bloated, so the percent of useful information is low comparing to size of the index, you may want to rebuild this index. This is basically the same as vacuum full for tables. It is done by reindex command. You can reindex some index or reindex all indexes on the table. Yeah.
Other index blocks select and updates?
Reindex blocks updates, but it doesn't block selects. It requires exclusive lock on your index and share lock on table, so you can use selects but not updates.
Select by the index or select without the index? You can use select using the index?
No, you can use selects which don't use this index being rebuilt. So you can use sequential scans or other indexes, but you can't update your table because you are reconstructing.
The systems has to be non-stop.
Can you rebuild indexes online or it's...
Yes, we can. I will talk about it. So basically just the same as vacuum full, and vacuum full in fact calls reindex for each index of the tables which is being vacuumed. And of course we have means to rebuild index concurrently without blocking. This is done by the following procedure. You can create another index on the same columns as the index that you want to rebuild.
But with a different name.
Yes, with different name. In fact, you can skip name and Postgres will choose it for you automatically, and it chooses quite meaningful names. Table name plus column names and IDX suffix, something like that. And you add concurrently keyword to this command. With this command, your index is creating concurrently. It doesn't block anything, but it creates a bit slower than just create index. And this command is not transactional. You can do it inside transaction, and occasionally this command can fail. So you must use it with some caution. If it completes with error, you have to delete, have to drop this non-usable index and repeat this command again. But when you create this index, you just drop index, old index that you have, and go on. Sometimes your index is used in integrity constraints and unique keys or primary key. In this case, you create unique index concurrently, and then in one command you drop old constraint and add the same constraint and specify index name to use. So this command will switch index which is used in your constraint.
If the index does not exist and you add a unique constraint, it creates the index?
Yes, it creates new index, but it will do it not concurrently, and this will block inserts, updates of your table. Okay. How can you estimate bloat of your tables? There are different methods for that. First, you can use system catalogs to estimate how much space your table occupies on disk, and then you know from statistics average length of your row version and number of rows in your table, so you can estimate useful amount of information and compare it to size of files, and so you can estimate your table bloat. In fact, query for that is quite complex because it must there are some corner cases and so on. You can find it in PostgreSQL wiki page. There are some versions of such queries. In your handouts, you have a link to that page. And I will show you another way by using pgstat-tuple extension. This extension basically reads all your table and gives you exact numbers of space usage. So create extension pgstat-tuple, it's standard extension. Then we create a table. I named it bloat. Insert some data in it, create an index, and we can select from pgstat-tuple function. What we can see here? We can see table length, number of rows, so on. Tuple percent is the number which is interesting for us. This is percentage of useful data in our table. Why not 100%? Because we have some overhead. We have page headers, some other structures inside our pages. So this is very rather high percentage, but not 100%. And the same we can do for indexes, pgstat-index function. Here the interesting number is average leaf density. it's basically the same. It's density of information, useful information in leaf pages of your B tree index. It's about 90%, rather high. And now we will update half of rows in our table. What we will get? Tuple percent decreased because 1/3 of our table now contains dead rows, dead row versions. So table bloated. And the same is true for index. Yeah. Sometimes it's not very convenient to read all table because it may be quite large. That's why this extension gives us pg.tuple approx function, which tries to approximate numbers by reading less data blocks. Yeah, and we have the same picture for indexes. Average leaf density also decreased, as you can see. So this way you can estimate your bloat and decide whether your auto vacuum is configured correctly, or you can use more aggressive settings, and whether it is time to rebuild your indexes. Yeah, that's all for this topic. If you have any questions, please ask. If you have no questions, then let's make lunch break. How many time do we need for lunch?